All right, so sigma, which means summation of I starts from 1, goes to 5. So the way we read the sigma means there's only one variable here, which is I, and they start at 1, end at 5. And the summation means you need to add them up. So they're going to be 1 plus 2 plus 3 plus 4 plus 5. So we stop at that point. This is a basic one. In your homework, I believe there are 2 parts. One of them said list them, 1 plus 2 plus 3 plus 4 plus 5. The second part, they ask you add them up. What is the answer? It looks like 15. So if this is part A and part B, you will put 15. All right? Adriana, that's a basic one. The more complex example will be sigma of x minus 5 squared. X start from 2, end up at 4. So in algebra part, our job is to simplify it. We don't need to understand which formula is this. For us, we just need to expand it and add them up. So we have a variable here, x, but the good thing is they give us x start from 2. So x going to be 2, then going to be 3, then x going to be 4. We stop at the max. So let's expand it. We have parenthesis minus 5 squared plus minus 5 squared plus minus 5 squared. So inside of the blank, here I have to put x, which is 2, then goes 3, then goes 4. We stop. Are you following me, Adrienne?
Oh yeah, I know how to solve it. It's just the putting it into the computer.
Very good. Yeah, I believe they ask you 2 parts. One part like this, another part like that.
Yeah, because I think I got it wrong because I put parenthesis over x.
Do you have exact question that I can solve it?
No, but it's just like that. But I see where I got it wrong now.
So now we're gonna start with the parenthesis. 2 minus 5 is negative 3 squared plus 3 minus 5 is negative 2 squared plus negative 1 squared. The next step, we're going to evaluate each parenthesis. Negative 3 squared is positive 9. This is positive 4. Negative 2 squared is 4. Minus 1 squared is 1. You add them, you get 14. So 14 will be the solution. All right. So I also have another example related to sigma, which is more complicated. And let's see which one is that. Maybe this one. This one. Yeah. So it looks complicated formula that what we're going to learn in this course in the statistic part. But now we only look at this one as, in the algebra part, we have to simplify. So the formula for expected value is this. We love it because they didn't ask us to talk about this formula, but they just ask us to substitute the value and find expected value. So what do we see here? We have sigma. This is addition. So we're going to add, correct? We have xi and we have p of xi. So if I start from 1 and goes to n, what is our n in this example? I start
Is
from
it,
1. What is that?
was it 4?
Very good. I start 1, the 1 term, 2 term, 3 terms, 4 terms. So stop at 4. Good. So that's great. So we get rid of n. Now we have x of I multiplied by p of xi. So now I'm going to expand this. I'm going to evaluate I. And I don't want to write sigma anymore. So there you're going to be x1 p of x1 plus this of the sigma x2 multiplied by p of x2 plus x3 multiplied by p of x3 plus x4 p of x4. Agree?
Yeah.
Thanks, Ryan. Thanks for joining us. Nikki, turn the camera on.
You want me to turn the camera on?
Yeah, why not? I mean, well, how many names should I?
I mean, I look the same.
It's up to you. Anybody else? Okay, anyway. You don't have to, man. Was joking. So now, so I took care of the sigma. Now let's plug the value. What is the value of x1? This is x, correct? Is 1. So x is actually x of 1 is 1. What is p of x1? Is 0.2. So 1 times 0.2 plus x of 2 is 2. P of x2 is 0.4 plus 3 times 0.3 plus 4 times 0.1. So now we're going to evaluate. 1 times 0.2 is 0.2 plus 0.8 plus 0.9 plus 0.1 by multiplying. If you add them, you get 1 here, 2.3, I believe, 2.3. This will be the expected value. Any question here? Naz, do you have question? Naz? That's strange.
So you just substituted basically with the numbers provided at the top.
Yes.
Okay.
Now, can you guys work on the second? So this was complex of sigma. Let's have this question. So I give you guys a formula. Again, this is part of the algebra. So forget about the statistic, we substitute, and here they ask us how many people. So read the question and then solve for n. All right, in order to solve for n, we need to know what is p, what is z, and what is e. We substitute it to that formula and we get n. So p is 34%. This is our probability p. And our error is plus minus 3%. This is our e. And we have z, which is 1.645.
So do we convert the percentages to decimals in order to?
Sure. Yeah, very good. So point plus minus 3% will be 0.03. 34% will be 0.34. So P will be 0.34, Z equal to 1.649, Z is 1.645. To change my pen. So n will be equal to 0.34, 1 minus 0.34, z is 1.645 divided by 0.03, this to power of 2. So the error has plus and minus 3%, but because we have square here, it doesn't matter if it's plus or minus, it will be plus. Can you guys evaluate this? Tell me what is n?
Is it 674.70?
600.
74.70.
I got that too.
So we rounded to 674 because we are talking about people. We don't want to cut the people. Correct? Has to be integers.
So we would round. Would we round up to 675?
Okay, 675. They didn't ask us, but that's fine. Very good, you rounded up. But for some reason, they should give us more info. All right, let's have another algebra. So at the beginning, it will look kind of strange, right? It's not solvable, but you need to look at it as a basic math with the ugly formula. Your job is to substitute. What about this one? This. So we are looking for how many cells must be made to have z-score of 2. So we are looking for x. Good. So first we substitute. We have, so the given, so we have a formula z equal to x minus mu over sigma. By now, all of them should make sense to you. But if not, that's okay, because we have, they said population mean is 2000. So population mean, so we are talking about mu, correct? Given mu equal to 2,841, and population standard deviation, which is sigma, equal to 895, and we have z-score equal to 2. In this formula, we have 4 variables. We have x, we have mu, we have sigma, and we have z. Mu we have, sigma we have, z we have. So we have one unknown, right? And we learn if you have one equation, one unknown, we are able to solve. If it were 2 unknowns, we need to have another formula. But this is one equation, one unknown. So we substitute. So I'm going to put 2 equal to x minus 2,841 divided by 895. So we have our equation here, which is one unknown. Correct. How do we solve for x? If this was an algebra question in your algebra course, so if you miss it, we said, okay, you don't get points. Or it would mean, if you don't solve it, we say, okay, you did a mistake. But in a statistic, if you did all the work, you come up with the formula, you plug it in, now you want to solve for x, and if you don't solve it correctly, it would be very painful, because you know the formula, you know all those variables, you know all the definition, you pick the right formula, you substitute them. Then little algebra, if you don't solve correctly for x, to me, that means you don't know the z-score. Correct? So in the algebra part, when you are here, you have to be very careful to solve for x without any mistake. Anybody solve for x here? Adrian, what'd you get? Did you solve it? You raise your hand.
Oh, no. I'm just solving it slow.
Okay. Ryan, did you solve it?
I'm trying it right now.
Okay, that's fine. Let's pick James. Don't do it in your head, James. You cannot do it. Syria. Musa, did you break the camera, or your camera's on? You don't want to turn it on?
I'm not picture ready.
No? I thought you
I
broke
just
the
came
camera.
back from work.
Okay,
Sorry.
that's fine. Group 4, Stephen, what is X?
Hello.
So we hear you. I would like to know what is X.
Oh, I just joined, so I'm kind of like don't know what we're really talking about.
I added 5 minutes ago, man. You're talking solid.
No way. That was not 5 minutes.
Okay, we are doing the algebra.
Yeah, I can see that.
Yeah, we're looking for this X. So the point was, I said it would be very bad if you, in a statistic, you write the formula, you do the substitution. That means you know the statistic very well. But in solving, if you do a mistake, to me, that means you don't know any of them. So when you're trying to solve, when you're dealing with digits, you have to be very careful. If this is kind of complicated, make an example. Say, for example, 5 equal to 2, no, not 2, x minus 10 divided by 8, for example. You just make one example. How do we solve for the x? In order to solve this, we have to get rid of the denominator. So I multiply by 8 both sides. Then I get 5 times 8 is 40. 40 equal to x minus 10. Then I have to get rid of negative 10. I add 10 to both sides. Then x equal to 50. Then I'm done. If I plug 50 here, 50 minus 10 is 40. 40 divided by 8 is 5. So this is just an example that you are capable to solve an equation like this with a smaller number. Now this is a bigger number, but we have a calculator. So I multiply by 895 to get rid of the denominator. 2 times 895 is
1790.
equal to x minus 2,841. I add 2,841 to both sides. I will get x, which is 1, 13, 16, 4,631. So how many cells must be made? 4,631. Any question here? Okay. Let's have a couple more algebra. So back to solving. Solve for x. 3x plus 12 equal to 42. What is x?
Is it
10?
10? Yeah. I just got 10.
Very good. So definitely we don't want to do it in our head. We have, the rule is get rid of 12, then get rid of 3, then x by itself, and we are done. So minus 12 minus 12. It was 30, 3x equal to 30 divided by 3, x equal to 10. Now another question. Radical, 2 radical x plus 5 equal to 55. What is x? So we're gonna solve, and solving is a big deal. I mean, not
I got 1500 is X.
1500, okay.
I think.
Anybody else? Okay, so we are looking for this x, and x happens to be inside of radical. So our job is to have the radical x. So our equation is in radical form. So we're gonna do the same thing, same as this example. I'm gonna get rid of this 5 and 2. So minus 5 minus 5, I get 2 radical x equal to 50 divided by 2 radical x equal to 25. So now what is x? How do I get rid of this radical? Sierra?
I was gonna say X is 5. I don't know.
No.
You get rid of the radical by squaring the.
Very good. We have to square it. So Sierra, that is 5. So is that radical 5 equal to 25?
No.
No, correct. So good try. Very good. But it's not correct. Not good. But thanks for sharing. So in order to get rid of the radical here, there is an invisible 2, it's a square root. So we have to square both sides. So now this is square and radical will go away. We have x equal to 25 squared, which is 625, I believe. Not what, 1500.
Yeah, for 1500, I got rid of the radical immediately. I did 55 squared. I messed up. Yeah.
Great. So we don't want to do that. Anytime you see a radical inside of your equation, and you know you have to square it at one point, that point should be at the end. Radical should be one side, everything else should be other side. Very good. Let's have another question, radical. Solve for x. We have 2 plus radical x minus 3 equal to 6. So equation like this is in, I will call it advanced algebra. So don't freak out. And you need to know the basic way to solve this. And there is no challenging question in your exam and homework, but you need to have some idea. So what we see a radical here. The goal is to have that radical one side, everything else other side. Can you try to solve this one? Nikki, what did you solve it?
Not yet.
Don't make me angry, man. Ryan, you solve it?
I got 39.
Anybody else?
Is it 19?
I got 49.
I got 19.
And I did it wrong.
Oh.
Yeah, I
Oh,
also
wait.
got
Oh, wait,
19.
I messed up.
Nikki, what did you say? What number did you say?
19.
You just pick between 39, 19, and 49? 19?
No, I got 19.
Okay, that's very interesting that all of them has 9 in it. You guys following a pattern. Very good. Let me solve it if I get 9 in it. So we have.
I realized my error. I got 19 as well. It's not. I didn't get there now.
Okay. We have radical. Everybody will back up. We will back up when you see equation radical. So that means we have to be super careful. The idea is we have to have radical one side. So this radical, instead of one package, has to be by itself one side. So this 2 is extra. Do I add 2, subtract 2, multiply 2, divide by 2 to get rid of that 2? We subtract, correct? Because it's plus, we subtract 2. So this is gone. We have radical x minus 3 equal to 4. So now we have radical by itself. Inside of your note sheet, you said if is a radical, like a x equal to 5, then we have to square both sides to get x by itself. So I'm gonna square this side and square the other side. This 2 cancel the radical, and x minus 3, it will be by itself equal to 4 squared equal to 16. So you can use a calculator if 4 squared is 16. Now I have to have x by itself. So I'm going to add 3 to both sides. Then you get x equal to 19. So 19 was correct.
Yeah,
Alright.
at first I forgot to subtract the 2. Like, I just got rid of the 2 on the left side. I forgot to change 6 to 4 after, and then that gave me 39. But
Yeah, I mean, if you see equal sign, whatever you do here, you must have over there.
yeah, I meant to do that. I wrote like the -2, but I just didn't do it.
Well, it's -5 for you. It's very important. But I mean, if I were you guys, I will write that note that don't do that mistake because it's important. But thanks for sharing, which is great. All right, let's go to statistic. Any question here? Any question for adding, subtracting? No, good. All right, last section in chapter 3 is 3.4, bootstrap confidence interval using percentile. Last week we talked about bootstrap. It was kind of interesting, right? The idea about bootstrap is, so main idea was we have a population. We cannot apply statistic in the big population. Here we get a sample of that. We study the sample, correct? We get all the statistic in the sample. We get enough sample to make a conclusion about the population. But Bootstrap said with one sample, we might have some idea about the population. So we have a sample. So population is somewhere else. That this is a sample of that. But we were able to get only one sample. From this sample, we pick Bootstrap sample. If our sample is 5, each Bootstrap should be 5 as well. If this is 500, each Bootstrap sample should be 500. And you know how to pick the Bootstrap sample. So the idea is we put them inside of, if there's a 5, we put them inside of the bag or hat. So you put 5 people here, and without we seeing them, we pick one, we write it down which one we picked, and we put it back, and we pick another one. So we do this for each Bootstrap sample. And we apply a statistic to each Bootstrap sample. Any question here? You guys understand the Mariana, is that okay?
Yes.
Yeah. So we applied a statistic to the Bootstrap sample, and we graph it. And from this distribution, so this called it Bootstrap distribution, each point here related to a statistic of one Bootstrap sample. So we're gonna have like a 10,000 Bootstrap sample to get the picture like this. With 4 or 5 samples, we cannot get something like this. So each dot probably is like a, I would say 100 or 500 sample here. Then we're gonna have a bell shape. There is a standard error, standard deviation of Bootstrap distribution. So we have standard deviation, which is same as standard error. Then we have margin of error for 95% confidence interval. Margin of error, same as before, is 2 multiplied by standard error. And the confidence interval will be a statistic plus minus margin of error. We had exactly same for the sampling, but now we're dealing with Bootstrap sampling. Another picture is here. We have an original sample. We have no problem to apply sample statistic to that sample. But we have only one sample. With this sample statistic, we cannot make a conclusion about entire population, right? What we do, we apply, from this original sample, we make Bootstrap sample, at least 10,000. Each sample, we apply the statistic. A statistic means, for example, we get the average height of each one. We graph them, it all happens to be some bell shape. Then we have a mean here. We have a standard deviation, standard error. And from this distribution, Bootstrap distribution, we are able to make some conclusion about population. So the outline is confidence interval based on Bootstrap percentile, which we will see it in a couple examples. Different level of confidence, different levels of confidence, impact of sample size, and level of confidence on interval width. Cautions for Bootstrap interval. So we're gonna go over this. Percentile method. If the Bootstrap distribution is approximately symmetric, So we are talking about when we get the sample, we apply a statistic to a sample, we will get some shape like this. This will be symmetric. This is a distribution. We can construct a confidence interval by finding the percentile in the bootstrap distribution so that the proportion of bootstrap statistic between the percentile matches the desired confidence interval. So we will see if we find 95% in confidence interval. So if that's 95% confidence interval, we have 5% left from 100%. So this part going to be 2.5%, and that going to be 2.5%. This is a better picture. So not all the time we are dealing with 95%. Sometimes 99% or 80% or 90%. Whatever P% is, this is going to be the center of P%. Correct? If it was 95, this much will be 95%, and 5% left, which we add this. If we add to tail, we should get 5%. Because it's symmetric, so this is going to be 2.5%, and this will be 2.5%. If P was 99%, if that was 99%, so 1% left, so 1% you divide it by 2, this is going to be 0.5%, and this is going to be 0.5%, which we add them, you get 1%. Again, it's beauty of the symmetry. This is what I said. For the P% confidence interval, keep the middle P% of bootstrap statistic. For 99% confidence interval, keep the middle 99%, leaving 5% in each tail. So 99% confidence interval would be 0.5 percentile and 99 percentile. In this point, if there was 99%, will be 0.5 percentile. I mean, 0.5% of data is there, and this will be 99.5 percentile, which is, I mean, this much data all the way to here will be 99.5%. 99.5 percentile. I mean, 99.5% of data is this way. These methods for creating a confidence interval only work if the bootstrap distribution is smooth and symmetric. All right, this is very important. In this course, most of the time is symmetric, all the time is symmetric. If it's not symmetric, so we cannot apply what we know. Always look at the plot of the bootstrap distribution. That means the plot should be like this. If the bootstrap distribution is highly skewed or look spiky with the gaps, you will need to go beyond introstats to create confidence interval. That means we cannot find the confidence interval if the data is something that there's a gap between each data set, each plot. There's an example here. Look at here, we have sample of 1,000, but what we got a big gap, and the data is like this. Definitely is not symmetric, so we cannot say anything about confidence interval. Good. Number of bootstrap samples. when using bootstrapping, you may get a slightly different confidence interval each time, which is fine. Good. And when we are using the StatKey, the website, whatever I get and what you guys gonna get, it will be different a little bit, which is fine. It's a random number. The more bootstrap samples you use, the more precise your answer will be, which is, this should make sense. More sample, better answer. For the purpose of this class, 1,000 bootstrap sample is fine. In real life, you probably want to take 10,000 or even 100,000 bootstrap samples. I mean, if you're gonna make a sample, we need to get a bag, put all the names in it, and get one by one, which it takes years to create one bootstrap distribution. But we apply computer, and computer will do it for us. So just click, 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 we get more sample. All right, one question for you guys. You have a bootstrap distribution here. Each dot represents what? One data value, one bootstrap statistic, n data value, 1,000 bootstrap statistic.
Is it A?
Almost, B is correct.
Uh,
Well, I know each one is one data value. I mean, each one is a data. But what kind of data is this? We are dealing with bootstrap distribution. That means there was a sample here. We pick 1,000 sample, and each sample we apply the statistic. For example, we find the X bar of this bootstrap sample, and we graphed it. So each one will be one bootstrap statistic.
oh, okay.
So each one represents, each one goes to this sample. We apply a statistic on that sample, if that was average or whatever they ask us. So each one will be a statistic. We know the statistic, correct? A statistic means, is that X bar, is that proportion, is standard deviation, correct? Those are the statistic. We have R, correct? So this is this one. Let's have another example. Which is wider, a 90% confidence interval or a 95% confidence interval?
Right?
95% confidence interval will be wider. Again, I mean, you need to visualize it. It should make sense. Now, what about this one? The larger the sample size, the wider, narrower the confidence interval. Sierra?
Wider?
No. No.
No. Okay. Well, then narrower.
Yeah, good. It will be narrower. So when we pick larger sample, that means we got to be more accurate because we took a lot of sample, correct? Then our confidence interval should be smaller, but narrower. For example, if the confidence interval was from 80 to 100, this distance is 20. So 20, this is an example, right? So 20 point between 80 to 100 is huge. But if you pick a lot of sample, if your sample size is bigger, we're gonna have interval of, let's say, 89 to 93. That means we narrow it down. We have more confidence because we have more sample. Our sample size is bigger, right? And we are looking for narrower confidence interval. You don't want to say, you don't want to present solution to a client, say, oh, we are 95% confidence interval, the answer is going to be between 80 to 100. It's a huge gap. But if you say between 89 to 93, so we narrow the solution.
Right.
Good. So that's another explanation. The larger the sample size, the smaller the variability in the bootstrap distribution, which will make the interval narrower. The larger the sample size, the more precise the estimate. Almost what I said. There's more. All right, let's do some homework question now. First question. So some of the homework questions you really need to go to StatKey. It's not possible without it. So let me, if I can. So they said 99. So we changed it to 99, correct? I was planning to take a picture of this. So they asked us 99% confidence interval. We did the 8,000, correct? And the image is here. So we have 99%, correct? From this interval to that interval. So this will be the answer. So the final answer will be from negative 0.130 to 0.040. Good. Pretty fast and simple if we just apply the StatKey website. What about this question? Sorry, I'm just lost now. So again, we need to go to StatKey. Can you guys do it as same as me? So we're gonna go to the data set will be American adult. So we are dealing with proportion again. So when we go to a stat key, we need to confidence interval. Those here is all the option. Are we dealing with the first one is confidence interval for a single mean, median, or standard deviation. Second one is for single proportion, which what we want, correct? We are looking for single proportion. What we done was for the previous question, we did confidence interval for difference in proportion. But now we're going to click on the second one, single proportion. So now we have to load our data sets. If that was about which data set should I load here?
I think it was the exercise.
Do we have it here?
Regular exercise, it's like the third from the bottom.
Yes, thank you. So I loaded. So we have 753 sample size, 1,000. Generate 1,000 sample, we get this, correct? They ask us 90%. So we have a standard error, everything on the top right. If you want to use a formula, but if you want to use this website, you're going to say to tail, correct? And they said 90%. So I'm going to change this one to 0.90. And this gives me an interval from 0.731 to 0.775, which is what I have here. Very good. So the answer here will be from 0.733 to 0.775. Any question here? Much easier than algebra, correct? If we know the technique how to navigate, is much easier than what we start the class today. All right. Now I give you guys a graph. Estimate the mean of the original sample of IQ score. Round your answer to the nearest integer. What do you think the answer will be? James, being very quiet.
Wait, what was the question again?
What is the mean?
One hundred and 100.104.
Very good, you got it. But if you read this one, they said round it to the nearest integer, so we will go with 100.
Okay.
Don't make it complicated. Part B. We can answer this one. The distribution was created using 5,000 bootstrap statistic. I mean, there's the first sentence, there are like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 words in it. Each word should make sense to you guys. use a distribution to estimate 99% confidence interval for the mean IQ score for the population. If we had a data, if it was active data, we will click on to tell, we get 99%, we get this 2 point, right? Done. But no, they didn't, they give us the plain, doesn't work. But 99% confidence interval here.
Would it be 86 to 114 if we're guessing?
Yeah, we have to guess. But they said 99%. So there are 99% of 5,000, correct? So what we do, we said, what is 99% or 0.99 times 5,000? If you multiply, what do we get?
4,950.
So 4,950 of data are going to be in 99%, right? How many points do we have? 5,000. We have 5,000 of those, correct?
Correct.
99% of them, which will be 4,950 we would like to collect. How much left? 50 left, correct?
Correct.
So it's going to be 25 this side and 25 that side.
Okay, got it.
But we need to count it. Get 1, 2, 3, 4, 5, 6, 7. Well, great. 8, 9, 10, 11, 12 probably. It's going to be around what I have it from. So also the other ends, we will count 25, right? So here going to be 99%. That means 4,950 dot we have 25. So this is going to be, I have it from 92 to 110. Right. Very good, Maria. Should we have one more and then let you guys go? I mean, that's actually your homework question. I saved you guys some times, but I don't want you guys just copy and paste. Hopefully you get a different answer, different number. So here we're going to use the stat keys. We are looking for 2 x's, correct? X of t minus, so difference mean. So I'm going to go to that side. I'm going to go to stats. So which one should I pick? Third one, correct? From top and bottom, you get third one. So CI for difference in mean, this one, I have to click. What did I do? I don't know. So now I'm going to go to that data set, which is about T and coffee. I cannot see, guys. It's getting old. Is that this one?
The one that says immunity, I think.
Immunity, yeah, that's the best choice we have. Immunity. So we have x1 minus x2. Yeah, we have tea and coffee. So this side we have. All right. So what was the question? So we're going to generate 1,000 sample to get some data. They said, what is x1 minus x2? The mean.
I don't remember the question.
Same here. They ask us, what is, okay. They said x of t minus x of, we need to estimate difference in mean production for the drinker minus coffee drinkers. So tea drinkers minus coffee. Okay, so memorize this for like 2 minutes, 5 seconds. So we need to do, so we have to make sure what is x2, what is x1. So original sample at the top. Here, we have x1 minus x2, which is 17.12. That's going to be original sample. That's what they ask. They didn't ask us to create anything. So this is going to be 17 minus 12, 17.12. From this data, we're going to get 17.12.
That was easy. Are they all going to be like that?
How it was easy? I mean, using the stat key, right?
Yes, just gives you the answer. So.
Yeah, I mean, that's how it works. I mean, in my age, we used to do it by hand, not even calculator. But again, using technology, being able to navigate through technology, that's the greatest skills these days. And in chapter 4 or 5, again, if you know how to navigate the computer, it's great. It's simple, easy A in this course. So here we got it. But you also need to know, I mean, with this data, you should be able to find x of t and x of c, right? You add them up, divided, it will gives us the answer. I mean, all right, what is the second part? Second part, standard error and 95%. So standard error and 95. I'm going to write it here to don't forget the question. So let's go back to that. So let me reset the plot. If we have only the original data, only one sample, that's all the number we had. And 1 is 11 and 2 is 12. I mean, we have the number of data about coffee was 10, number of about tea was 11. And difference mean was 17.2. And here we have sample 0, mean NaN, I mean, is null, standard error is null. We cannot calculate those things. So now we're going to generate bootstrap sampling. I'm going to generate like 1,000. Now we see a number here. Good. So what they ask us, the standard error. So it would be 7.94. We have it here, correct?
Okay.
7.94. And they ask us 95%. 95%, you can use the formula plus minus a standard error, a statistic plus minus a standard error, or we can use this two-tail. And we are doing 95, so it's already 95%. It gives us the interval from 0.86 to 30.5. 409. Correct, this will be the interval. If I add another sample, 1.95, another sample, troughs. This is 0.925. You have to get 95%. You said 95%, correct? So 0.95.
95.
So 1.35 to 31.64. So this is, they said 95%, so you have to change the model to 95%. All right, what I have here, standard error, I have 7.9 and 1.32 to 32.92, I have it. I record everything, not this question probably. So this was not recorded, so they ask us proportion of female, which is 16/169 minus proportion of male, which is 27/193. It gives us 0.045. And for confidence interval, we use the stat key. All right, guys. I have one more activity for you guys, which we don't have time. Any question for me?